Today we are going to discuss about how to draw a distance time graph. So first of all, what is a distance time graph? Hope you have all learned about what is distance and time, and we are going to plot these two, that is distance and time, in a graph. So what is the need for drawing a distance time graph? A distance time graph shows how far an object has traveled in a given time. So it can denote how much time it took for an object to cover a certain distance. And it is in simple ways we can say that it is a line graph that denotes distance versus time findings on the graph. Next, why should we draw a distance time graph? What is the need for a distance? Why do we need to draw a distance time graph? Basically, it helps us to identify the type of motion. So an object can be at rest or in motion. If the object is changing its position with respect to time, we can say that it is in motion. And if it's not changing its position with respect to time, it is at rest. For motion, we can say that it can be uniform or non-uniform. Uniform motion is observed when the object travels equal distances in equal intervals of time. And if the object is accelerating or speeding up in an uneven manner, we can say that it is a non-uniform motion, which means it covers different distances or uneven distances in different intervals of time. And basically why we are drawing this distance time graph is to find out the speed of the object in each interval of time or at any instant of time. So next we are going to plot the distance time graph. So what we require to plot a distance time graph is basically the distance and the time values. So here I have taken some values of distance and time. Distance is given in meter and time is taken in seconds here. So at first both these are at zero position, and then the distance traveled is 2 meter for the first 5 seconds, and for the next 5 seconds, that is when it becomes 10 seconds, it covers a total of 4 meter. So you can see there is a 5 seconds difference here and a 2 meter difference here. Again, after completing 5 more seconds, that is when it becomes 15 seconds, it covers another 2 meter. So here again 2 meter distance is covered, which shows that it is covering equal distances in equal intervals of time. So now we are going to plot the distance and time. So first we have to mark the distance in the y-axis as shown here, and the time should be taken in the x-axis. You can see here time is taken in the x-axis, and here the distance is taken in the y-axis. And you can see here that the scale of the graph, you have to first carefully take the scale of the graph to note down any values. So from here 0, it starts from 0 and the distance stops at 10. So here we have distance from 0 to 8. So this is okay for us. So we can plot it in this graph and see for the time. For our time, the minimum value is 0 and the maximum value is 20. So here as you can see, it starts from 0 to 10. So we have to scale down this and make it up to 20. So now I have taken a much more bigger scale so that all these values will be included here. So here the distance is taken in y-axis and the time is taken in the x-axis. As you can see, I have taken for each unit, I have taken 2 meter. Here each unit represents 2 meter of distance, and in time, that is x-axis, I have taken each unit as 5 seconds. So first 5 seconds is in one unit, next 5 seconds in next unit, and so on. So now we can plot this graph easily. So how to plot a graph? First of all, you have to mark the position where both distance and time is coming together, that is at 0 0, both of them are there. So first point we mark here, you can see that small dot, and in the next one, that is when the object travels 2-meter distance and the time is 5 seconds, we can see that these two, that is here 2 and 5, they both join at this point. So at this point, you can say is a position we have to mark. And similarly, the next one, that is when the object is going at 4-meter, when the object travels 4-meter, you can see it comes up to here, and the time taken is 10 seconds. So you can see it comes up to this mark. Again we plot the next one, and similarly we go on, that is at 6-meter distance, as you can see here, the 15 seconds. So we can see this comes up to here, and next one again 8-meter is given in 20 seconds, and so on. So now as you can see, there are points which are marked for each of them. So 0 and the distance at 2-meter and 5 seconds, the distance at 4-meter for 10 seconds, and so on. So what we have to do is we can draw different types of graphs, and here distance time graph is a line graph. That means we are marking these or joining these points to form a line. So as you can see, now we have plotted a line covering all these points, and we get a straight line. So before I had told that if the object covers equal distances in equal intervals of time, we can call it as a uniform motion. So currently I can say that this is a type of uniform motion. So I hope you have understood how to draw a distance time graph. And why do we need the distance time graph? We can find the speed as well as we can interpret what type of motion the object is moving. So here the types of distance time graphs. So similarly, if I had taken 4 different values of distance and time graph, I can see that in this case you can see at 0 time the object is at 3-meter distance, this, and again at 5 seconds again it is at 3 meter distance. Even at 10 seconds it is still at the same 3-meter second, and 15 second again it is at 3-meter distance. So we can see that all these points are at the same distance. So we can say that there is no change of position with respect to time. Even though the time is changing every 5 seconds, there is no change in the position of the object. So we can say that this object is in rest. So the body is in rest when the graph is in a straight line, that is straight horizontal line parallel to the x-axis or the time axis, then we can say the body is in rest. Next type of distance time graph is the one we had plotted. So here as you can see, here it covers every 2-meter in every 5 seconds. So the first 2-meter is covered in the first 5 seconds. The next 2-meter from 4 to 2 is covered in the next 5 seconds again, that is from 5 to 10. again 6 to 4, that is again another 2 meter is covered during the next one, that is 10 to 15, that is 5. So in every 5 seconds it is covering 2 meter distance. So we can say that it is covering equal distances in equal intervals of time. Therefore this is also known as a uniform motion. So the distance time graph for a body in uniform motion will be a straight line which is positively inclined. As you here, as you can see here, it is positively inclined. It is not a horizontal line as we had seen in the earlier case. This is a positively inclined straight line. So this represents a body in uniform motion. The next one is non-uniform motion. We know that most of the objects travel in non-uniform motion. So one of the examples we can say in the previous case is that for uniform motion is object falling, like a, an apple or a coconut falling from the tree can be said as a uniform motion, and in this case that is non-uniform motion. We can say, we can see here that the first 5 seconds they are covering almost 2 meter, and in the next 5 seconds it is covering almost up to 8 meters. In the next 5 seconds again it is covering up to some 15 or 12 meter. So it is covering uneven distances. So we can say that since these are covering uneven distances in different intervals of time, we can say that the body is in non-uniform motion. So since you have seen how the different types of motion is represented in a diagram, you can revise yourself by checking out what are the types of motion denoted here. So if you check this one, here 5 meter is covered in 5 seconds. So first of all, you can revise what is written, what should be written for the y-axis. So here it should be the distance. Distance should be given in meter in the y-axis, and for the case of the x-axis we have to plot this time. Time is given in seconds. So as you can see, x-axis is given by time and y-axis is given by distance. So now checking this type of motion here in A, that is from 0 to 10 seconds we are checking. So for the first 5 meter it is being covered in first 5 seconds because the point is found here. The next 5 seconds, that is from 5 to 10 seconds, it is again covered. It has again covered 5 to 10, that is 5 meter distance again. So the difference between 0 to 5 is 5 meter. Again difference between 10 to 5 is again 5 meter. So we can say for every 5 seconds it has covered 5 meter distance. So we can say from this position at 0 till time 10 seconds the body is in uniform motion. Then what about the B part? That is from 10 seconds to the next 15 seconds. How is the body moving? Here as you can see, for 10 to 15 seconds, first 5 seconds it had covered only 5 meter, but in the next 5 it has covered more than nearly 20 meters, because the difference between 30 and 10 is 20. So here it has gone even higher, so it is more than 20. So the distance time graph, as you can see here, shows that in the next 5 seconds it has traveled more than 20 meters, and thereby showing it is a non-uniform motion. So here it was covering only 5 meters in every 5 seconds, but here it has covered more than 20 meter in this 5 seconds. So we can say that B part is in non-uniform motion. Otherwise, you can also say that the body has accelerated. Accelerated means it has highly gained speed. And what about the C part? As you can see, I have told you that the graph which shows horizontally or which is parallel to the time axis, we can say that it is in rest. So the body, after it covered up to nearly 32 meters at 15 seconds, from 15 seconds till the next 25 seconds, you can see that even though the time is changing for every 5 seconds, the position of the object hasn't changed. It is still at the same position of 32 meters. And so we can say that the part C denotes body is in rest. So the first part A is in uniform motion because it has covered equal intervals of distance or equal distances in equal intervals of time, and the part B is in non-uniform motion as compared to A because it has covered more distance in 5 seconds, and the part C, it has not changed its position even when the time is changing, so we can say that it is at rest. So I hope you have identified the types of motion from this graph, and I hope you have understood how to interpret a distance time graph as well as how to draw or plot a distance time graph. Thank you for watching.